Neat. Germans call Wednesday the middle of the week, which it is.
It really shouldn't be.
All right, listen up. Any questions on the review? Questions on the review? Who's absent today?
I am. Wait, Donovan.
I see no one is absent. No one is excellent. Good. All right, let's get going here. No questions? All right, did I give you the answers? No, I did not. All right, so I'm going to collect these. I'm going to collect these. All right, so somebody, Grayson, grab the box that says course 2, and that's not it. Collect the homework and give the handout for someone to hand out for me, please. Thank you. All right, for everyone else, looking at the calendar here, I've got a quiz next Wednesday, so we're going to knock out some classes here. Today is a calculator class. I didn't tell you that, but today and I believe tomorrow is calculator. There's a couple of the ones. We will not be using calculators for the test. However, if you want to use a calculator for tonight's homework, you can. Here's your homework. Landon, quick. Now, our book, we're in the geometry section, one of 2 geometry sections. You would think that after what we had, building blocks, points, segments, rays, and lines, that we would immediately switch to polygons, shapes like triangles, quadrilaterals, that sort of thing. This year, the book decides we're going to throw circles, the very next thing. Go figure. Yes, Jace.
Can I go grab my calculator?
If there's one person in this class that doesn't need a calculator, my man, it's you, right? You'll be fine. But yeah, we finished the class earlier. Let's go get it. I had a clicker somewhere. If I were a clicker, I would be right there. Okay. All right. The exception of Abby and Grayson. You guys got the homework copy now? All right, here we go.
No.
All right, circles. 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 All right, there's a lot of things to do right here, a lot of things. And I said today would be a calculator, right? Only because you're going to be dealing with pi and whatnot. It just makes your life a little bit easier. All right, write this down, please. Box 1. Notice box 1 has 3 boxes. 3 boxes. Okay. We're going to talk about a shape that's made initially by taking a central point and putting it somewhere on your paper. So you take a point and you put it somewhere on your paper. Then you either take this measuring device called a compass, or you take this measuring device called a ruler, and you measure a certain distance away from that given point. So for instance, this is in centimeters. If I go 10 centimeters to the right and I put a dot right there, great. If I go 10 centimeters on the other direction and put a dot, great. I'm going to build up a shape by doing this process. Measuring from a central point a certain distance. I don't change the distance. I make it the same. So go down 10 centimeters, put a dot. Go up 10 centimeters, put a dot. Looks like I'm making a square, right? If I play connect the black dots, I'd make a square right now. But I don't stop at 4 dots. I continue to measure 10 centimeters away in all directions. I continue to place more dots. And the more dots that I place, eventually it starts to look like a circle. So what is the definition of a circle? That are
10 inches away.
always 10
Always the same.
from a,
Different point.
now you got to put one extra thing and it's got to be on a flat surface. Because if it wasn't on the flat surface and it was all the points that are set 10 centimeters away, Jace, you would make a?
Sphere.
You'd make a sphere. So if we restrict it to a flat surface, you make a, so that's the definition, right? This is what a circle is. It's the set of all points. That just means all the points, right? The collection of all the points, right? Take your pencil, right? Thank you. The set of all points on a plane, flat surface, that are the same distance away from a given point. You're like, well, I thought a circle was just a round thing, right? No, we have a more formal definition. It's the set of all points, not just some of them, but all the points on a plane, on a flat surface, that are the same distance from a given point. If you take out the word on a plane, that's the definition of a sphere. The set of all points that are the same distance away from a given point. But if you restrict it to a flat surface, a plane, then you make a circle. Hey, the kicker is this. Is the red dot part of the circle?
No.
But the red dot is how you make the circle, kind of paradoxically. Also, when we think about circles, typically we think about the center part, yes? Is the center part of the circle?
No.
It's not. The circle is only the curvy part, right? The center isn't part of your circle. Although we will generally color it. The word that defines the whole thing is anybody know? What would be the shape that would include the center? Now, a cylinder would be 3 dimensions. This is 2 dimensions. Closer, clearly not a square. Well, a circle is just the black portion. If we include the middle part, we make a that's actually the right. So we just don't call it. We would call it a disc. If you said disc, good for you. You got it. All right. So in that first box, you still haven't written it. Write the definition down, and it's almost too late because I'm going to the next slide. In that first box, in box 1, you have the definition. In the second box, draw me that circle. Yes, I made it blue, but the blue part is not part of the circle. Nor is the A part of the circle. Did you already look at my slides? All right. We name circles with either the word circle and the point that we made the circle from, the center point, or we use a symbol for a circle. Anybody want to take a wild guess at what the circle is? The symbol for the circle is? Okay, it's not, but it's close. All right. Believe it or not, it is the astronomical symbol for the sun. Anybody know what that symbol is?
Like with the
Okay. There are 7 objects that you can see in the sky. Not talking about clouds. I'm talking about astronomical objects. Those 7 objects are with your naked eye. So let's see. We got the sun.
stars, galaxies.
Well, stars are kind of hard. The big objects that you can see. What's the next biggest thing you can see? The moon, right? So apparently I can't hear you today, Brett. The moon. What else can we see? Well, which planet that you can see? You can't see Pluto, and Pluto's not a planet. You can see Mars. You can see
Jupiter.
You can see Saturn. You can see
Uranus.
you can see Mars. Somebody said. You can see you can see Mercury. It's very small, but you can see it with your naked eye. You can see. You said what else? Oh, green. Well, stars don't have. There's too many of them. We can see Saturn. We can see Jupiter. Nobody said. You can see. I did give myself enough space here. 7. 1, 2, 3, 4, 5. There's 2 left. Venus and. Hey, please stop. And plus, you can't see it with the naked eye. You can't.
Neptune.
You can't see Pluto, Neptune, or Uranus with the naked eye. You can't see it. Right? You can see one of them you can see with binoculars. They better be pretty darn big binoculars, but the other 3, the other 2 you can't see. What's the last thing you can see with the naked eye? Saturn. Okay. So I'm not good at this, but the astronomical symbol for the moon is that shape right there. Moon, crescent moon. It's a waxing crescent moon. Anybody know the symbol for Mars?
It's like
It's a person with a spear, because Mars was the god of war. This is also a symbol for men, right? Symbol for Mercury. Mercury was the
God of hearts. God of men.
he was the messenger of the gods. He's always depicted with wings. So the symbol for Mercury kind of looks like the devil, but it's not. It's actually his wings, right? Jupiter, the symbol is.
A trident.
You probably don't know. It looks like that.
Oh, I've seen
It looks
that.
like a 4.
Yeah, it looks like a 2.
Symbol for Venus is it's girls. It's a girl holding a mirror. This is a mirror. Go figure, right? That's pretty sexist. And Saturn Saturn is also the god of agriculture. When you harvest crops, you use a tool called a scythe or a scythe, right? And this is the symbol for it. Some would argue it doesn't look much like that, but you can kind of see if I leave off the plus part, there's the sickle side, right? All right, so those are the symbol, which leaves one left over, which is the symbol for sun, which is
Like a bunch of lines.
The circle.
It's a line. I knew it. With a dot.
okay. Oh, by the way, this is the symbol for circles. And now do you want your head to explode?
Well,
No.
The 7 objects that you can see in the sky are also the name of the sun day. Mun day. In Spanish, Mars is.
Tuesday.
Two.
In Spanish, Mars is. Somebody speaks Spanish or Latin. It's Martis, right? Or Mardi, right? And Mardi is, if you're Spanish or you speak Italian or you speak Latin, you call it Mars Day. We don't call it Mars Day, we call it
Wednesday.
because in Norse mythology, T-I-W, Tua is the god of war. This is why we get Tuesday, Tua's Day. This is where Tuesday comes. It's the god. It's the same thing. It's the god of war. Mercury.
Wednesday.
Well, in Norse mythology, the guy that carried the messages to everyone was called Woden,
I knew it.
and Woden is where we get Wednesday from. So both Tuesday and Wednesday, the same gods. It's the same words, except it's Norse mythology where we get the names of the week. Jupiter. Why is that Thursday? Jupiter, right, or Zeus, right, in Greek mythology, Jupiter or Zeus throws what from the sky? So does in Norse mythology, who throws lightning?
Jupiter.
Thor, which is why Thursday is called Thor's Day. Venus is Friday. Once again, in English, we get many of our words from not Greek or Roman mythology, but from Norse mythology. And the god of love, beauty, and sex is Venus, right? And in Norse mythology, that person is, anybody know?
Friday.
Okay, it's Freya. It's Freya. Please stay with me. And Freya is where we get the word Friday from. So Friday is Venus Day, right? And lastly, you can all see where we get Saturday from. It's from Saturn. By the way, this is where the words come from. So if you've ever wondered why we get these names, they all come from mythology. Every single one of them. The 7 days of our weeks are all named, with exception of the sun and the moon, are all named after gods or goddesses. Go figure, right? And by the way, the majority of people that go around the world do not know this. Now, obviously, other societies have different, but all Europeans, right? This is the name of the days of their weeks. Okay. All right. Back to circles. I brought all that up because the symbol for a circle is the astronomical symbol for the sun, and obviously the sun is a circle. It's a sphere, right? But when we look, the sky appears 2 dimensions to us. So write this down in that second box there. I asked you to draw the shape, and the name of it is either the word circle A or the symbol, astronomical symbol for sun, and an A. The third box is, well, not yet, but this is circle Z, right? Either way. All right, and they are nicely drawn, right? By the way, there's the symbol for Uranus, Neptune, and Pluto. Pluto is named after the guy that predicted that we would find it, Percival Lowell, which is why it's PL. All right. Okay. Box 2A. Box 2A. If you place, Jana, you're not paying any attention. If you place 2 points on the circle, no, the circle is not the yellow part, it's the the curved part. If you play 2 dots on a circle and you play connect the dots, you have made a,
Circle.
you've made a segment. A segment that is connecting 2 endpoints that are on a circle gets a special name. It is called a. The people that are making jokes need to stop right now. Okay? If you put 2 points on a circle and you play connect the dots, yes, you've made a segment, but you've made a special segment. We call it a. No one remembers from last year? Nope. Write this down, please, box 2A. This is called a C-H-O-R-D, a chord.
All right.
A chord is a segment whose endpoints are on a circle. Just remember, yes, I made my circle yellow, but really that's the disk. The circle is the black portion. It's the curved portion. 2 points on a circle. If you play connect the dots, you make a chord. That's 2A. You made a chord. You need to write this down. We're on box 2, not box 1. Yes, everybody? All right. There's a big complicated shape. It'll look like this for homework. They will give you the question, name the chords. Name the chords. So Jackie, name your chord. Is A and C on the circle? Yes, so AC is a chord, right? Somebody else, Abby, give me a name of a different chord on the circle. She gave me AC, and that's the same as CA. EX is X on the circle, therefore it can't be a chord. You see another chord up there? FG, that's the only other chord up there. EX is not a chord, okay? So on circle X, right, you have AC or CA, and you have FG or GM. All right, box 2B. You see it on your paper? Name your chords. I'm going to take all this stuff away from you right now. Now, do it. Box 2B.
At the beginning.
Yeah.
Why couldn't be
X is not on the circle. The definition of a chord are it connects 2 points that are on the circle. All right. Let me catch up. All right, 2B, we'll pick up Breckton, name a chord on 2B. BA is on the chord, is a chord. What do you got, Christian? DB, those are the only 2 chords, right? Now remember, BD is the same as DB. Segments can be named in any order. All right, done with chords. All right, think about this, right? If I make a chord, if I make AB right there, and I talk about staying on the circle. Now I'm going to stay on the circle. Remember, chord AB goes through a circle, right? Now I'm going to stay on the red part. What's the name of that thing? Absolutely not. It's not a diameter or radius. By the way, diameter and radii are not on a circle. They connect points on a circle. What's that thing in red I just made?
part of the curve?
Part of the curve of the circle. And it's got a name. It has 3 letters. It is called a? Starts with the letter A.
Arc.
It is called an arc. Write this down. It is part of a circle formed by 2 points. This is going to get complicated. Jenna, write. Formed between 2 points on a circle. Arcs get a little bit complicated. Chords don't get complicated at all. Arcs can get a little complicated. Hey, you need to write the definition.
Part of the circle.
All right. Now, if the arc makes half of a circle, we call it a semicircle. Semicircle. Include this, please. Semicircle. It's an arc, but it contains half of the circle. In other words, if the 2 points on the circle are actually the 2 endpoints of its, anybody? You guys have been trying to say the word from the start of class. Diameter, right? Then it makes, if you go around the circle, it makes a semicircle. There are two semicircles. Which begs the question, which one am I talking about? Am I talking about the top one or the bottom one?
Bottom
It-
semicircle.
B.
This is where arcs get a little bit more complicated. Right? All right, so am I talking about the top one or am I talking about the bottom one? Well, that becomes a problem if I only have 2 points. Therefore, for semicircles and larger arcs, we need to use, instead of 2 points, we need to use 3 points. Okay. Okay, next one, box 3, the word that you've been trying to use from the start. If you connect 2 points and that chord goes through the center, then that is called a, all right, write that down. We're on box 3A. That's what a diameter is. It's a chord, right? Not an arc, it's a chord, and it passes through the center of the circle. Maybe arc was the first and only new vocabulary. Semicircle, I know you've heard of semicircle, but arc should have been probably, if you had good math teachers in the past, the only new word so far. You've had chord before, you definitely had diameter before, and the rest of the words that we use today. All right, diameter, chord that passes through the center of a circle. So guess what I'm going to have you do in box 3B? Name the diameter, box 3B. Now, there can be an infinite number of diameters. Oh, and all, by the way, for any given circle, all the diameters have the same measurements. And they're segments. So when you list them, you got to put the little segment symbol over the top. So 3B, name the segment, Amanda, or name the diameter. You got to talk loud and proud. I can't hear you. I can't hear what she's saying. What'd she say? EM, because E and M are on the circle, yes? When I say on the circle, what do I mean on the circle? Circle is not the blue. The circle is the curved black line. Is M on the curve? M's not on the circle, so it can't be a diameter. Which segment goes from 2 points on the circle through the middle, Amanda? Somebody interpret, I can't hear her.
J and H.
J and H. J goes through H and it goes to the center, yes? If I go from J to H, I go through the center. The definition says I go from one endpoint on the circle to another endpoint and I go through the center. What's the only segment up there that does that? Thank you. So it's a chord, right? So on circle M, though, it would be LK or KL. Notice I'm putting segment symbols up there. Yes? Everybody? Easy or hard? These are just definitions. Just definitions. All right, box 3B. Now it's your job. Name all the diameters. I put plural. It could be singular. Everybody done?
Yeah.
Okay. Angie, what's the diameter? DB or BD? Either one. Yes? Easy or hard? It's just definitions. Remember, you can always put definition on your reason. Hey, we're almost done. The last one. Why did I say we're going to use a calculator? Because we're going to calculate the perimeter of a circle. All right. We still have a couple more vocabulary words to get to. Okay. The one that Amanda and some else of you were trying to use is, what do you call the thing that goes from the center to a point on a circle? Okay, that is called a radius, plural radii. So the definition of a radius, box 4A, definition of a radius is a segment that has one endpoint on the circle and the other one is the center. That's called a radius, plural radii. I don't have the word radii up there. Radius, radii. Once again, I had most of you last year, I know we did this in course 1. We also did circumference as well, too. So the only new word was arc today from the lesson from last year. And semicircle as well. Semicircle is a form of an arc. So we got circle, definition. We have chord, definition. We have arc. We have semicircle. We have diameter. We have radius. 6 vocabulary words today. We got one left, circumference. But Those are all the vocab words for today. All right, just as we did in the past, somebody new, what do you got? Olivia, how many radii do you see? So the definition says it starts at the center and goes to a point on the circle. So what do you see? GB, she said, GE and GD. So all of those are radii. GE, it starts from the center. So like a ray, it's important the way you put your letters. So we're always going to start for radii. We're going to start at the center and go outward. So GE, GD, and GD. Notice that GD and GB together make a, and the relationship mathematically between a diameter and a radius is what? What's the mathematical relationship between a diameter and a radius? Say again?
You need 2 radii to create
2
1
radii make 1 diameter. 1 diameter is equal to 2 radii. 1 radii is equal to half a diameter. Either way, you want to say that. 2 radii make a diameter, or half a diameter make a radius. Make sense? Genevieve, new or old hat? All right, have you heard this before? Okay. All right, box 4B, same drill. Name the radii. Name the radii. In 5, 4, 3, 2, 1. Smalley, give me the radii.
All of it?
Yeah, give me all of them.
Okay. XB, XD, and XC.
Well, clearly he's got it. All right. You guys got it? All right. All right, we're kind of skipping around. So tonight for homework, they're going to give you one shape and they're going to ask all of those questions that we said. So the 6 or 7 vocabulary words we had. They're going to ask you to name the circle. This is box 5A. This is circle, Avery, circle. This is circle B. By the way, there's only one way to name the circle. All right. Gabby, give me 2 chords that are not diameters. Ooh, tricky question. 2 chords that are not diameters. Well, the definition of a chord is it has to go from one point on the circle to another. She said DE. That's cool. And it didn't go through the center. DE and FG. You could say GF or ED as well, too. Okay? So either way. Yes? Math teachers love this question. Give me something that's this but not that. Okay? Remember, it's still the same circle. How about Grayson? You tell me all the radii up there. We're going to start with the center, always for radius. BA, BC, BG, and BG. Okay, so there's 4 of them. Okay? Yes? Easy? Right?
And the diameter.
All right. Callie, what is AC and DG? It's a what? Now, she could have said chord. Would she be right?
Yes.
Yeah, but the most specific name for it is, well, it's a chord that goes to the center. Therefore, both of those are diameters. Is everybody tracking? Easy day, right? Now on your own, all by yourself, do box 6. So I'm asking for chords, diameters, and radii. Chords, diameters, and radii. Box 6. Name them all. Chords, diameters, and radii. Anybody lost? Remember there's segments, so you got to put a segment symbol at the top. That's chord. Is that all the chords you see? Give them all. Give me them all. I'm greedy. I want them all. Hey, both of you, turn around. Get to work. First one's wrong. Give me all the chords, it says. Not the different ways to name it, but give me all the chords. You gave me 2 of them. There's more than 2. Anybody lost? Priscilla, tell me all the chords that you see. BA is a chord. AD is a chord. BD.
No, CD.
CD is a chord. I can see at least one more. CB. Now, you might argue that AC is a chord. Technically, that's true, right? We would give it a more specific name. If you put AC there, good on you. I would never mark that wrong. All right. Kai, what's the diameter? AC is the only diameter. It is the only chord that goes. There's other things that go to the center, but AC is the only chord that goes to the center. Yes? All right, Hannah, give me all the radii. We start with the center always. Got it? All right, easy money. I see no problems. Yeah, last one. Okay, here we go. Flip it over. 7A, new vocabulary. The distance around the circle is called, well, technically it's the perimeter, right? Perimeter is how we define the distance around an object. Circles are special, right? They get a special name for their perimeter. They call it the circumference. So write that down. It's the distance around the circle. It has nothing to do with the yellow part. It's just how far it is around. Anyone want to take a guess on how early man measured the circumference? What? With a box? No.
Like how to measure it?
Well, how would you, if I give you a circle, how are you going to measure the circumference?
With
I
a
don't know.
tape measure.
They didn't have tape measures. What did they do? They didn't, before they did that. This is how they discovered that. What did they do, Genevieve?
Like go, like look at the diameter.
Nope. Before they did that. Here's a circle in blue. How do I measure how far it is around? Anybody? Couple different ways you can do it. One of the easiest way to do it is put a mark on it. Put it on a flat surface and roll it. When it comes back to that mark, you just made a line on the flat surface, measure that line. Another way is take a string, measure it with a string, and then hold the string up to your ruler, right? There's a mechanical way of measuring a circle. Obviously, we're not going to look today at the mechanical way, but that's what they did. So early human beings could measure the diameter, measure the circumference of a circle. They found something very interesting. When they measured any circle, I mean any circle, and they measured the circumference, and they measured the diameter, and they divided the two, guess what happened? They got this magical number, 3.14. And by the way, it works for any circle. Not just small circles, not big circles, any circle. If you measure the circumference and you divide it by its diameter, you get 3.14. So smart people, not me, smart people came up with a formula for measuring because they kept getting the same number for any circle. Well, that's pretty cool because if you take that, you divide it by diameter, you get 3.14. Now, pi is, you've heard it before, and I've told you before, pi is the Greek letter, P. That symbol that you guys have been writing is how you write your name if your name is Peter in Greek. Your name is Peter, you write it with that symbol, that's the P. Right? P is also the first letter of the word perimeter. Right? That's where it kind of comes from. So write this down, please, 7B. Pi. You take any circumference of a circle and divide it by its diameter, you get 3.14. It's an irrational number. That means it never stops and never repeats itself. Well, that's a problem when you do calculations. So how do we solve that problem? We round. Tonight for homework, when you're doing your circumference, you can't use an equal sign. You must use an approximation symbol. That's the two wiggles. Okay? Pi is that symbol. This is lowercase p, right? So I guess if your name is Peter, you wouldn't use that letter. But if you want to say, I don't speak Greek, I can say a couple words, but that's about it. But if you want to say pizza in Greek, you spell it with that letter right there. If we have time, I'll Google pizzeria Greek and see what it says on the sign. And it's going to have that letter right there. All right. Tonight for homework, you're going to have the option. You can either on your calculator type in 3.14. If it's a fraction, use 22 over 7. 22 over 7 is close to pi. It's not pi, but it's close. Secondly, if you want to use the actual pi symbol, by the way, your calculator still rounds. On this, I'm looking. Here's her pi. It's right there. If you press it, you get an approximation. It goes up to 3.141592654. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. It's not pi. When you use that symbol, it's still rounding, but it's rounding to 9 decimal places. You use 3.14, you're rounding to 2 decimal places. Okay. I'll show you. All right, so write this down, please. So we just figured out that you can take circumference, divide it by diameter, and you get pi. It's pretty easy to do a little bit of algebra to get that formula. I'll show you the algebra real quick. We just said if you take the circumference and you divide it by the diameter, you get pi. What would happen if I multiplied both sides by the letter D? What would happen to the D's over here? And you'd be left with that formula right there. That's where the formula comes from. Just a little bit of algebra. Circumference. You take 3.14, you multiply by the diameter, poof, you're done. But wait a minute, we said that a diameter is equal to, why am I holding up 2? A diameter is equal to 2. So you can have a second formula to further confuse you, is that instead of saying pi times d, you could say pi times 2 radii. Make sense? So in most math books, they have a second formula for circumference. They have that, which is, I hate this because it confuses students. Why don't you just stick to pi times d? So I would prefer that you just remember this form. This one is just confusing. Jaden.
If you were to divide the circumference by 5, would you get the diameter?
If you were to take of a specific circle, yes. All right. Yes.
So if it's a radius for me, I just stretch it all the way.
Just double it and then you got your diameter. Yeah. All right. Remember, circumference is a fancy word for perimeter. So here's how it's done. To calculate the circumference, you take pi, you multiply it by the diameter. Is that a diameter or a radius? It's a diameter. If it's a radius, double it, you got a diameter. So I'm going to use c equals pi d. So I take that. Now remember, as soon as you change from the symbol to 3.14, you are rounding, Jenna. You are rounding. So I need to change it from an equal sign to the approximation symbol. So I take 3.14 and multiply it by the diameter. In this case, it's 10. That's easy money. You get that answer. By the way, since we're doing a calculation of distance, we need to put units in inches. IN is inches. Yes? Not new. This is not an 8th grade math thing. You guys did this in 5th and 6th grade. Okay? Hey, is that a diameter or radius?
Radius.
A smart student would say, well, what's the diameter? So you do 3.14 times 4. Other students are like, nope, I want to use the formula. Well, if they give you a radius, then you use the 2 pi r formula. Easier students, they just double it and use the pi d formula. All right, I'll show you 2 pi r for those who want to see it. This says it's 2 radii as a diameter, so it's still the same formula. As soon as I put 3.14, I got to change the equal sign to approximation symbol. So it's 2 times pi, which is approximately 3.14, times the radius, which in this case is 2. You got to calculate this is no big deal. If you're doing this by hand, what should you do first? You're doing this by hand.
2 and 2.
Remember, multiplication is commutative, right? I can move them in any order I want. I'm going to do 2 times 2 first before I multiply it by 3.14. Save the decimal stuff to the very end. So that's 4 times 3.14, which is approximately 12.56. Who am I losing? What part?
Well, no, I'm not lost. I just have a question.
So that was the question. Who am I losing? No one? All right, question?
All right, so how many decimal places do you go?
So if we use 3.14, it's going to automatically be 2 decimal places.
So like, say it's like 7 times 3.4, we go.
Just
The answer, then
the
2
answer
decimal
is the answer, okay? All right. Now notice, if I had originally used pi d, I'd be multiplying, well, double 2 is 4. It'd be 4 times 3.14. I still get the same darn answer. I just think it's easier just to always mess around with diameter, and that way you don't need to memorize two different formulas. The real reason I don't like this formula, anybody know? I'm circling you learners, I'm circling 2 pi r. The real reason I don't like it is because,
There's more work.
no, you say about work.
The way it says, if you're doing an order.
Because the formula for area is
Oh,
2 times pi.
pi r squared. You still got a 2, you still got a pi, and you got an r. For most students that aren't familiar, these two cause problems. Because each formula has a 2, a pi, and an r in it. So some students will make a mistake between the two. So me, I don't even like to use the 2 pi r. I just think it'll confuse students. So I'd say just use pi d every single time. Plus, as soon as we do area, we won't do area for another couple chapters. When we do area, kids will mistake circumference and area. All right, box 9, you have 3 problems in front of you. Do them, please. I said today was a calculator day, so you can use calculator. Use 3.14, but if you're curious about where the pi key is, it's right there. It's blue, so you need to use second and that key. Do it. So if you want to type in pi, second, that, and it literally puts the symbol pi. Anybody lost on what to do? Which part? Okay, so write the formula first. C for circumference equals pi times diameter. First circle, what's diameter? So we're going to do 5 times pi. Pi is 3.14 approximately. So it's 5 times 3.14. And then put the units and you're done. Yes, you do. You just don't know where it is. Hand me your calculator. Above my finger.
Hey, Mr. Chartier,
Yes.
could you show
run
me
this?
how to get the pi symbol on the
What calculator do you have? What calculator do you have?
I have the science one and then that big expensive
What's the
one.
name of it? What's the name of it?
Okay, I'm going to get.
He doesn't even have any desk in the question.
Cut him some slack.
He's not home. He's in his pajamas. Leave him alone.
Probably is. Probably is. He's probably still going gone a bit.
He's probably just laying down in bed.
What?
Here, I'll just show you.
He's got a TI-30.
And then there's a bigger one.
A TI-30. He's got a different version of that one. He's got a TI-30. No, he's got.
And then I have the TI 84 Plus.
TI-84 Plus. It is on the.
Oh, it's right by the clear button.
Where is it?
Right by the clear.
Look at the clear button on the TI-84.
It's above. It's below.
It's blue. You see it?
Is it this one?
Oh, on this calculator it's right here.
Yes, Donovan.
Okay.
On the other calculator, it's. Where is it, Breckton?
Oh, I know where it is. There's the second, and then it's
Look on your other calculator. Look on the left side. It's the 4th button down from the top.
Oh, okay, I see it.
Thank you.
Hi.
All right, here we go. First one, since Angie did it, and I saw her do it, I'm sure she has the right answer. The answer is how much? 15.7. What? Monkeys, snakes, gorillas, what? Inches. Very good. Yes? Now, just make sure you put the approximation symbols. Jenna, you got the middle one. What's the answer? What? So you could have done it by hand, right? You're just multiplying by 3.14. Whatever answer. Final answer is it's two numbers multiplied together. Come on, Jenna, you can do this. 6.28. Thank you, Jenna. All right, the last one. What do you got? Priscilla, what do you got? Can't hear what you said. What?
I don't know if it's right.
What? Give me the answer. Let's use some common sense here. Hey, what's the diameter of this one?
3, 6.
Oh,
6. Pi is about 3. 6 times 3 is,
18.
did she get a number that's about 18?
No.
So that can't be the right answer. Go ahead, Priscilla, finish it. If you want to use 2 pi r, it's 2 times pi times the radius. The answer is? Priscilla, come on.
I don't know how to multiply it.
Hey, Jade, let me handle this.
Yes.
Priscilla, do you want to use pi d or do you want to use 2 pi r as your choice? Do you want to use pi d or do you want to use 2 pi r? We use pi d, we're using the diameter. If we use 2 pi r, we're using the radius. All right, thank you. Yes, everyone?
Yeah.
When would you ever use 22/7? I said use that as pi.
If your diameter or radius
Is a fraction. So check it out. If they tell you the diameter is 14/11, hint, 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 this is on the homework, right? This is the one they want you to use 22/7. So we would still, circumference is equal to pi times d. Instead of using 3.14, we're going to use 22/7. So we would write it like this, 22/7. They're going to give you numbers that there's some cross reduction quickly done. See what I mean? Cross reduce, this turns into a 2 times 2 is, so the answer is 4, right? Approximately 4, correct. Okay, so the answer is approximately 4 centimeters. I think there's only 1, maybe 2 of these tonight for homework. When you see a fraction as a radius or diameter, they want you to use 22/7. All right, challenge question.
Easy.
If I tell you the circumference, could you calculate the radius?
Yes. No. Yes. Yes.
Okay, everyone pay attention, the last thing. If I give you the circumference, can you calculate the radius? Are you paying attention? I know Jenna's not because she's not looking at the board. But here's how this is done. They give you the circumference. Well, I know there's a formula. It says find the radius. So I want to use c equals 2 pi r. And I'm going to plug in what do I know. What do I know? Is the, so I replace c with that. I replace pi with approximately 3.14, and I just do some geometry or some algebra. What's 2 times 3.14?
6.28.
And then what am I going to do to both sides? Divide both sides by 6.28. All right. What's up?
I didn't get time to
Landon.
finish it, so I just had to do it. I didn't have time to finish
Take
it,
your other
so
stuff,
I
too.
finished it really fast.
Okay. Give it to me. All right, e-learners, any questions before I close this?
Dominic.
No, I'm okay.
All right, see you tomorrow, Donovan.
Bye, Donovan.
Bye. Bye, guys.